Okay, hi guys. This is part 2 of finding determinant. So by now, you should know how to calculate determinant of a 2 by 2 matrix. So before proceeding into calculating 3 by 3 and n by n matrix, we need to know the definition of a minor and a cofactor. So given here are definitions of minor and cofactor. Let A be an n by n matrix. So then Mij is determinant of n minus 1 times n minus 1 matrix obtained from A by deleting the ith row and the jth column of A. Mij is called the minor of entry Aij. Next, cofactor is given by the formula -1 to the power of I plus j times the minor of ij. So in simpler words, if I plus j is even, then we multiply the minor with +1. If I plus j is odd, then we multiply the minor with -1. Now we look at an example. Consider the matrix A with row vectors 2, 2, 4, 0, 1, 5, and 6, 3, 4. Then the minor of entry 1, A12 is obtained by deleting row 1 and column 2. We need to calculate the determinant of a 2 by 2 matrix of column vectors 0, 6, and 5, 4. So multiply 0 and 4, we get 0. Minus 5 times 6, you get 30. And so the minor of entry A12 is -30. Now to find the cofactor of entry A12, we multiply -1 to the power of 1 plus 2 with the minor of entry A12. So in this example, the cofactor is equal to -1 to the power of 3 times the minor, which is -30. And therefore, the cofactor that we obtain is equal to 30. Okay, now we can continue with finding determinants using cofactor expansion for n by n matrix. So given here is the formula. Determinant of A is equal to A11 times C11 plus A12 times C12, and you can continue that until you get the entry of A1n times C1n. So C here is the cofactor that we have looked upon earlier. This is also called the Laplace expansion of the determinant of A along the first row. So this is indicated by the subscript 1. Determinant can be evaluated by using cofactors expansion along any row or column. But usually we will choose the one with the most zeros to avoid the computation of some of the cofactors. Of course, to better understand the cofactor expansion, we will go through an example. And so we try to find the determinant of the following matrix, 3 by 3 matrix, by expanding along the first row. So taking the first entry 3, we delete row 1 and column 1. Therefore, determinant of A would be equal to 3 times the remaining matrix after deleting row 1 and column 1. Have 2, 3, 2, 4. And so because the cofactors have the alternating sign, the next entry would be 5. So we put the -5. And we delete the first row and the second column. So we multiply with 4, 3, -1, 4. And finally, for entry 2, we plus 2, and we delete the first row, third column. We multiply with 4, 2, negative 1, 2. Next, we just simplify the calculation by finding each of the cofactors. We have 3 times 4 times 2, which is 8, minus 3 times 2, which is 6, minus 5 times 4 times 6, that would be 16, minus negative 3, that would be plus 3, plus 2 times 4 times 2, that would be 8, minus negative 2, that would be plus 2. Further simplifying, we have 3 times 2 minus 5 times 19 plus 2 times 10. So we have 6 minus, how much you get there? 95 plus 20. And so you will get the answer of negative 69. And so there you have it. That's how you calculate determinant of a 3 by 3 matrix using cofactor expansion by expanding along the first row. So you can also calculate using expansion along any row or column and get the same answer. And be sure to try that yourself. In the next example, we look at determinant of 4 by 4 matrix.